Well, good morning and good afternoon and good evening, depending on where you are. My name is Hristo Aladjov, and I'm the Secretary of the American Society for Cellular and Computational Toxicology. And welcome to today's webinar on Effectopedia. Before we get started, I just want to give a couple of brief housekeeping issues. So please, while the webinar is going on, mute your lines until the question and answer period is done, or until the question and answer period, to cut down on background noise. And as a reminder, as you just heard, this webinar is being recorded. We'll send out a link and make a link available on our website for viewing afterwards. Just briefly, the ASCCT is a new North American society dedicated to providing scientists working on in vitro and in silico toxicology testing methods a home to collaborate and learn from one another. If you are not a member, please consider supporting programs like these by joining. And the website where you can find more information is www.ascctalks.org. So our presenters today are Dr. Gilman Veith. He is chairman of the board of directors for the International QSAR Foundation and former director of effects research at US EPA. Dr. Hristo Aladjov is a senior scientist with the Bulgarian Academy of Sciences in Sofia. So go right ahead.
Thank you, Christy, and thank you, all of you, for signing in and showing interest in the development of Effectopedia, the topic that Hristo will describe here in just a few minutes. But by way of introducing this topic, I'd just like to describe how we arrived at this point and why we're involved in it. I think the need for in silico methods, computational toxicology, has really been highlighted by some of the recent legislative agendas in Europe and elsewhere, and they're based on the fact of that probably 80 to 90% of the chemicals that have to be dealt with by regulators are just simply do not have the necessary test data to proceed with a conventional regulatory risk assessment, which is driven by animal test data by and large. And one of those alternatives, or the alternative methods aimed at trying to reduce the animal testing, is the use of the predictive toxicology, both from the point of view of more diagnostic methods, as well as quantitative structure-activity relationships, which have been long used by the drug field for drug design, but also in a number of limited cases in risk assessment by EPA. The International QSAR Foundation is a non-profit research group, and its mission basically is to promote the development, I guess I should say, of QSAR methods for regulatory purposes. And we work solely with government agencies and universities and researchers to implement our research program. We do not have a large staff of our own, but one of the flagship conferences of the foundation are the McKim conferences, which took as a purpose the discussion of or understanding what the barriers were to using in silico methods like QSAR in regulatory risk assessment. And we arrived at kind of two major technical barriers that we should focus our program on. And one was the first was the fact that obviously metabolism often changes chemical structure so that the effects of chemicals cannot be really predicted by the parent chemical structure. And in fact, we have to have a whole family of chemicals associated with a given chemical to really assess the chemical. The second thing was that the QSAR models really are reliable for molecular interactions, and the toxicity endpoints which are tightly linked to those molecular events. But when you come to long-term disease progression and effects that cascade from the cellular level up to whole animal effects, there are so many other variables that are that enter into the problem that the QSAR model for molecular interactions isn't sufficient. Our program is addressing the metabolism issue by supporting the development of metabolic simulators for many kinds of test guidelines and specific tissues, as well as running a consortium of governments now who are working to harmonize the collection of metabolism data and improve these metabolic simulators. But tools such as the QSAR toolbox that is being used, supported now by the European Chemical Agency, can provide this bridge over the gap to understand what kinds of active metabolites are likely to be present in various tissues, given a parent chemical that's being assessed. And in fact, the metabolism assessment, or the review of metabolism pathways, is a major part of their grouping chemicals and the risk assessment itself. And then the second part of this is how do we get how do we get past the idea of QSAR models working at the molecular level when we're really interested in vivo effects? And that brought about the concept of adverse outcome pathways, which are, for our purposes, we describe these basically as biological response models that causally link biological effects from the molecular initiating
Zoe and Carol from Clorox?
From the molecular initiating events all the way up to whole animal effects over time. These biological response models and the amount of data and knowledge that are needed to make a reliable and robust response model becomes very complex, as you all know, and we needed a way of organizing this information and using it in a modeling scenario. And Hristo Aladjov is a very bright computer scientist in the Bulgarian Academy of Sciences and has been in the U.S. Under an NRC postdoc position for some time, and conceived this approach to organizing the data, and is going to just show you kind of our work in progress here on developing Effectopedia. So without any further comments, and I apologize for the lengthy introduction, but I'll turn it over to Hristo.
Well, thank you, Gil, and thank you, Christy, for the invitation and opportunity for hosting this meeting. I will just make one step back again to illustrate the idea of what the place of adverse outcome pathway is in the whole set of of different concepts. So basically, toxicity pathways are probably the most let's say the very small concept, which encompass only the molecular initiating events, or organelle and cellular level effects. And we can go further to mode of action, which actually propagates follows the development of the effect and propagation of the dysfunction to the individual level effect. And we think that adverse outcome pathways are actually covering everything from exposure to population effect. And this is where the current efforts of Effectopedia are made to encompass those. But in general, in future, probably source to outcome pathways will be really the future application of Effectopedia, encompassing everything from source to community level effects. Some, let's say, typical examples of way adverse outcome pathways were represented before is just the linear structure of chain of events. And we also have some supplementary information at what level of biological organization this might happen, and those are the two examples. One is for estrogen binding, and the other is for developmental neurotoxicity, which I will revisit afterwards in Effectopedia application. So what we have currently is a vast wealth of expert knowledge, which is not presented in any computational form. We have a lot of partial pathways, metabolic trees, and we have a lot of test data which propagates from acute to chronic and various medias like in vivo, in vitro, in chemical. And we also have this division between public and proprietary data. And all of these data is actually in incompatible formats and really does not speak to each other. And on top of this, we have this huge complexity of which Gil already talked about. If we try to describe all molecular mechanisms that are involved in certain adverse outcome pathway, we have very complex multiple feedback systems which are hard to follow, and they also require a lot of multidisciplinary knowledge to be able to describe them properly. And again, all of this information is sitting as bits and pieces in different repositories or even on paper. So our idea with Effectopedia was actually to get all the things organized in some more understandable way. And probably the core idea behind this organization is to present a pathway as a combination of a flow chart which has the cause, link, and effect. So we represent the causal linkage in this way, and also as a diagram, because this flow chart is also spread around a coordinate system. So every box in this system shows different, for example, level of biological organization, time scale, and I will show you later what possible axes we can choose. But to return back to cause, link, effect notion, I would like to say that first we have in link properties we might have to distinguish between two types of logical connection. One is the quantitative connection between the cause and the effect, and the other one is the qualitative. The quantitative connection actually expresses what amount of disturbance at the cause level actually will cause effects, and we can have very many different relationships here. We can have a threshold, we can have a dose response if it comes to from a chemical to a molecular initiating event, or we can have a response to response when it comes to propagating the effect from higher levels of biological organization or from organ to whole animal. And we also have the other side of this link, which is the qualitative part, which actually tries to explain why and what are mostly molecular mechanisms that are explaining how this effect actually works. But we have to really keep separate the two things, because one is just kind of prove that this really happens in reality and some explanation, and the other is really the quantitative part that could be used for some kind of hazard assessment and vulnerability analysis and many other purposes. And also I will make a brief point on what the effects are, and we don't have a very formal definition of effects, but those are some forms of observable loss of function of the particular cell, organ, or some biological system. So I would like to show you how these pathways are actually located in more complex space, and you can usually choose a few axes to display it and project it on, but basically the space gives us the opportunity to put all the effects close together in a space, in a confined space, where all similar effects actually that will have, for example, in this case, all the effects that are on organelle level that have that are for male species and are midterm will be located basically very close to each other visually in space. So you can, when you enter a new effect, you can actually be advised by surrounding effects and see if this effect is not already in the system. And this also gives us really very robust way to set up the context for the effect and describe, for example, what exactly life stage this effect occurs, in what species, and again what gender and so forth. So, and those axes are actually customizable by the user. So the way you wanna dissect the information could be really very flexible. So how we define a pathway, as Gil said, some of the chemicals are probably not going to be causing any disturbances in the biological system. So we have at some points we have metabolic activation, and active metabolite is actually the chemical that starts the whole pathway. This starts with triggering the molecular initiating event, and from then on we have a series of effects which are propagation of this initial dysfunctional change of the function to the adverse outcome. And usually we have data for chemical causing several molecular initiating events, and we might have some information on what is the next level of biological organization that is affected, for example, in what organelle or which cell type this molecular initiating event actually is located and is working. And we also have at the adverse outcome pathways, we also have some long-term data, and we have some idea that this chemical is causing the adverse outcome, but we usually don't have the intermediate steps. That's why the idea of building a pathway is actually breaking the complexity by starting to build the pathway from both ends and meet somewhere in the middle. And some additional mechanisms in which the pathways are actually enriched in information is if we have some effect, and we can see that in Effectopedia there are two downstream effects listed, and if you are expert in the field, and you might be able to actually answer this question: what are other downstream effects that you know that are actually caused by this initial effect? And by creating this link, you actually create a piece of a pathway that somebody else might actually continue following you. And this is the same as used in the opposite direction. If we have effect X, we can actually ask ourselves what are other possible ways to cause this effect. And on molecular level, this could be, for example, molecular initiating event, and we might ask what are other possible chemicals which might lead to this effect. And here, for example, will be the place for QSAR models and other predictive tools. And I can probably now go to show you the application itself. If Christy could switch the desktop for me.
You're all set, Hristo. You can just minimize the
Okay.
no.
So the Effectopedia application in its current pre-launch form is actually available from effectopedia.org/go. This link will be shown further down on the presentation, but this is exactly the same application I'm launching now from Christie's desktop. And the application actually has intention to be a very user-friendly and have a lot of context-sensitive help, which will guide the user how to use it most properly. And I should say that the application that you are going to see now is basically the editor's part of the whole project. Most of the users will be probably seeing only the created pathways, and they will be able to just view them, minimize them, or drag through the effects in them and have the textual description, but they don't have to really work hard to get the information. And those pages will be statically generated and will be indexed by normal process of search engine. So it's very much like Wikipedia nowadays is a very common explanation link for a lot of things that we look for in internet. We hope someday Effectopedia will be one of the places you would go to understand what are the actually mechanisms in which certain chemical cause certain adverse outcome pathway. And what I'm going to show you now is, for example, how one existing pathway looks like in Effectopedia. And for example, I will look for estrogen binding. And currently I'm looking at the Effectopedia is very modular application, so currently I'm looking at local memory, but in general this could be your local database, it could be the global Effectopedia database or some internal database of the company you work on, and you can look for a pathway or just fragment of pathway links and things like that. So what we have here is basically a very similar to Google search results. We have one pathway found, and here is the name of the pathway, and we can see some keywords and some fragments of this pathway, what is actually composing it. If I click on the pathway, I'm loading it into the viewer, and this is also a editor.
Oh, you're killing me.
So now I'm trying to zoom out. I hope that everybody's display actually is refreshed properly. And currently it's not intended to be readable. I mean, I will zoom it a little bit more. But what I'm willing to show you now is basically that we have the pathway displayed on two axes. The y-axis here is gender, and x-axis is level of biological organization. And we have two example chemicals, octylphenol and aminoaniline. And we can see that they actually have very different ways of causing one and the same adverse outcome pathway, which is population reduction. And these diverse ways are actually gender specific for both chemicals. We can see that I will zoom a little bit. In males, for example, it causes different alternation of sexual organs, and in females, if I remember correctly, it causes reduced egg production, and let me see. I apologize for the not very smooth driving of the screen, but it's involved in many steps. This way I'm controlling Christie's desktop. That's why it's not like it's on my own. But for example, we have reduced fertility as a effect of the both chemicals, and I will just go and expand some of the boxes here so you get a better idea of what type of information we are collecting.
And then when you get exposed, what is terming the molecular initiating event which is working on the part of the GDIE.
So let me just go here.
If it binds say to HFA, when it binds to HFA, what kind of
Excuse me for a minute. Could people put their lines on? Thank you.
What kind of
so what I'm going to do now is try to expand the binding to the estrogen receptor. This is the molecular initiating event of this pathway. And you can see that it is now loaded in a separate editor. And we have here in the middle we have the effect description, and on left side we have the causes, and on the right side we have the actually effects and following effects. And we have, for a description, we have the normal function of estrogen receptor, And what actually the effect causes is disrupt this function. And we also have provided here the context of this effect, which is molecular in terms of level of biological organization. We also we don't have specified, for example, the life stage in which this occurs, or all of the other axes, but we also have specified that here this effect is actually occurring in both males and females. And if we go back to, just let me move this thing. I don't know if I will be able to.
Is that what you wanted?
No, I just wanted to. There is a control here which is in my way to switch back to the editor, Effectopedia web editor. I don't know if I will be able to. It's yes, this is the view. So I'm back to the effect, and you can see that the effects are actually located in these regions here. For example, this molecular initiating event that I've just opened is actually at molecular level, and it's mixed gender. And when we go to the cellular level, we can see that there is a ER transcription factor as a downstream effect, and this actually follows different other effects for male and female. And I would like to show you also a different example of a pathway. Just if I can come here and load another example. So this will be weak acid respiratory uncoupling. And what I wanted to show you in this example is that if we use the standard axis that we just used for the estrogen binding pathway, which were gender and levels of biological organization, this pathway actually looks very linear. But if we choose a different perspective to the same pathway, which is current time to effect in terms, I will explain what that means. The effect actually becomes somewhat more branched structure, because we have things that start in short term. We have, for example, chemical causing the molecular initiating event at the molecular level, and then everything goes to tissue level, where we have reduced ATP production. But depending on how long we have this function actually in place, we will have a midterm effect, which will be increased metabolism, or in long-term effect, we will have heart muscle failure and even followed by death. So basically, depending on what type of information you think that the pathway will be most comprehensive, you can choose the axis and make different observations of how things are spread. Besides, for viewing pathways, we can have also a lot of wiki-like features. For example, if an expert starts editing some of those boxes, the original contributor will receive a notification by email that somebody made a change to his contribution. Also, if, for example, biologist is filling up the gaps at from tissue to organ levels and connect some existing pathway to a new pathway, the original designer of the existing pathway will also get some form of mail notification, and they might establish some form of contact, and because this is basically where their interests are actually crossing, they have viewed one and the same effect through different experiments in different levels, in different actually levels of comprehension and understanding of this effect. So this is part of the ways we are hoping to encourage interaction between users of the Effectopedia. Also, we have a lot of things in mind for making the contribution knowledge to Effectopedia as easy as possible. So all these chemicals that are going to be included in Effectopedia are with their chemical properties, structure, and everything else could be easily popped out from existing databases and just employ it into the system. We also have all the references and everything else that is accompanying the description of molecular initiating event or a pathway to be actually extracted easily from online search engines, which is currently just an idea which is not implemented. But for example, here we have the references supporting this particular molecular initiating event, and those are most of the times the explanatory, so to speak, qualitative references that explain why this effect actually occurs. And if I can go back to welcome page here, there are also a lot of other options if some experts are actually willing to make a note on an existing pathway, or they disagree with what is stated there, they actually can very easily go to the specific box or specific place where they have for some different opinion. They can just make automatic comment on this, and the discussion hopefully will clarify what the best and most agreeable way to describe, for example, certain molecular initiating event is. And we also have a ways to prevent the system from getting flooded out with unwanted advertisements and things that are really not relevant to the Effectopedia. So we can see exactly like in the Wikipedia, we have a mechanism for people who had contributed previously to Effectopedia and gained some respect in the system to be able to actually reverse edits made by unknown editors or new editors. And you can see the current history of edits here, and this is also a visual history, so you can see that every item in this history is actually encoded as a for example, I can click on this one, which is the title of estrogen binding was modified, so you can actually reverse this to original title or make a new one, or just collaboratively edit the whole pathway. I probably will go back now to the presentation again, and if you have any further question for the Effectopedia, we can go back and take a look at it during the question session. So basically, Effectopedia is entirely open source, and the content of Effectopedia is also going to be something that is contributed by users and owned by users. So it's again free and available information referenced by peer-reviewed literature. The technologies that are currently used for Effectopedia are Java. It's purely Java written code, and the database support is MySQL and PostgreSQL. So it's going to be actually flexible depending on what server the user wants to use, and depending on the load, it could be switched between the two servers. Also, we try to build upon existing and very formally described formats, so we don't invent anything new. And the storage language of the pathways are actually XML based, and we also look for supporting some of the existing formats that are also XML based. Also, I did mention that Effectopedia will have two phases. One is the one that you usually will see by just browsing and making a search in the search engine, and you will see simple HTML pages that will include the description of the pathway, broken in sections for each effect, and how those effects are linked with quantitative and qualitative links. We also have the idea to include as many as possible options for third parties to involve their units and make some additional features of Effectopedia, or also vice versa. The whole functionality of Effectopedia is actually available as a web API, so other applications could actually access and make electronic inquiries. For example, after this molecular initiating event, what is the pathways that are followed and that occur, and Effectopedia can give as a result all the pathways that are stored in Effectopedia, and this could be linked up to any other application. Also, the whole idea is actually to come up with the glossary of terms that are actually agreeable between experts. So experts with different backgrounds hopefully will be able to edit one and the same pathway, because a lot of times it's not really enough for a chemist or toxicologist or biologist to contribute the whole pathway, but its different pieces are actually contributed by different people, and they have to know that they are talking in the same language. So again, we will have this glossary set up and discussed in very collaborative manner. Just a little bit about the architecture. The idea is not to show any technical details, but the fact that actually Effectopedia could be used as a standalone application if we use just the core engine plus some local files, or we can use, for example, in industry setting, for example, we can have proprietary server running all the knowledge that industry wants to preserve in the same format as adverse outcome pathways, but having the advantage that this knowledge is actually kept only for their private views, along with the ability to actually access the public knowledge and mix it in one and the same format. this will hopefully provide some good ways of communicating the knowledge between private and public sectors. So the idea of the whole architecture is really to make as many and flexible combination as the users might require. And I will skip about the details. Basically, as I said, the whole project is open source and available under general public license. The source code itself is hosted on sourceforge.net, and this demo that I just launched is available at effectopedia.org/go. I will just reiterate a little bit again the features of some of the features of Effectopedia, which are, for example, the ability to establish this discussion between the contributors. For example, they will receive those instant notifications if anything that they contributed to Effectopedia is actually linked by other users. We also envision a way of small companies to be able to actually fund data gap challenges, so experts all over the world will be able to fill in the data and provide some possible initial literature search and knowledge about what are the possible pathways, for example, that follow from a certain chemical. Also, we hope that this system will allow people to make much more elaborate analysis. For example, we will have ability to filter pathways depending on the species or exposure. We also have idea to create so-called vulnerability slider, which will allow to actually find out which is the most vulnerable system in as a sequence of a given chemical, which will basically prioritize the most sensitive, for example, cell type, which will disrupt its function and then propagate to the higher levels. And all of those features are actually really easily implemented based on only the information which users are contributed to the system. And also this system is envisioned to be able to help forming categories and help also QSR methods to be applicable to long-term effects that are actually explained by biology, but only the QSR part will work only up to the initial molecular initiating event. And hopefully Effectopedia will also aid the hazard assessment by basically cataloging all the molecular initiating events and available adverse outcome pathways. Every test guideline also will be represented in Effectopedia, and this is going to be done both by voluntary efforts and also by workshops. So probably I will conclude with this and give you some time for questions. And I just want to say that this project so far has been supported by International QSAR Foundation, in part by Bulgarian Academy of Sciences, and just 2 grants from OECD and National Science Foundation. And thank you for your attention.
Thank you, Hristo. If there are any questions, please just go ahead and speak up.
Well, people are, this is Gil Veith, people are collecting their thoughts, perhaps, let me just say that I think some of the immediate complexities that Effectopedia will be addressing will be, and one is the fact that very few chemicals do one thing when they initiate adverse effects or toxicity at any level of measurement. That is, chemicals have many different kinds of interactions, and the very specific ones, like on known receptors, are probably fewer than 1,000 QSAR models, where not only the model for binding, but also the boundaries, chemical boundaries, so what kinds of structures can bind to this kind of receptor, are fairly well known and have been loaded up. A little more complex version would be very non-specific interactions, for example, with electrophiles binding to either soft sites or hard sites in DNA, and the reactive chemistry tends to be rather non-specific, and so the profiler to take a chemical and say what kinds of molecular initiating events can this chemical cause based on the literature, that capability already exists as part of the toolbox. They call it a chemical profiler. And so in an example where Hristo showed a phenol and an aniline, alkyl aniline, they both are capable of binding to the estrogen receptor at comparable levels. And so reproductive effects in an in vivo test generally show up at about the same level. But there are lots of other effects that amyl aniline causes, due primarily because it also can lead to formation of methemoglobin, and you have a whole cascade of effects from a completely different pathway. And when we look just at case studies and look at all the effects that are caused, unraveling what effects came from what kinds of pathways and initiating events is a central complexity that I think we can unravel reasonably soon. I think a more difficult one is the kind of the bridge from going from molecular effects to in vivo effects, and I think we are approaching that by getting some focus groups together. For example, looking at how many different ways you can cause mitochondrial dysfunction, and then trying to link the long-term disease progression from different kinds of different ways of disrupting or causing dysfunction in mitochondria. Some of the clinical researchers involved in this, identified 20 human clinical diseases that seem to be attributed to back to specific effects in the mitochondria. And another group in the World Health Organization that we're hoping to work with is kind of focusing on liver dysfunction, everything from cancer to lots of different effects, and how can we begin with a specific type of tissue or organ and start organizing the effects that one sees in a repeat dose assay or a carcinogenicity assay. So we'll probably be focusing on just specific better studied phenomenon and then grow out from these different points. Be willing to entertain questions with either Hristo or I.
Hi, so this is Irene Abraham. My question is, whenever you were talking about the forming categories and the use of toxicology data with case studies, is that referring to kind of the IPCS effort to get a better idea of what's going on within the toxicology and the molecular pathways?
I think, Hristo, correct me if I'm wrong, but in this case, the categories that he's referring to is the grouping of chemicals in more of a regulatory context by, let's say, the European Chemicals Agency or other agencies. There is the OECD in Paris has put out guidelines for forming chemicals. For chemical categories. And the idea is that we won't have quantitative models for predicting, the effects of chemicals de novo especially for long-term effects for some time. But if there are some chemicals, if a chemical belongs to a category of similar chemicals and some of those members have been tested, then they developed a read-across method to try to estimate the same test endpoint from its similar neighbors. And this is basically what QSAR is taking existing data, training sets, and extrapolating between them or estimating from known data and scaling data as long as you have a chemical that you know is behaving similarly. And so the QSAR effort is part of it is really to make sure that the chemicals are expected to behave similarly toxicologically. And there's a formal process or guidelines of OECD countries that will group chemicals and form a chemical category. So you can use the data, and maybe, for example, there may be 250 aldehydes in production, and 4 of them have long-term animal test data. Then you can try to estimate or scale to the other members that haven't been tested yet, and that. So I don't think it was really in a. It's scientific, but I don't think it's in a scientific sense necessarily.
Thank you.
Are there any more questions? Okay, well, I would like to thank everybody for participating, and I'd like to especially thank Dr. Veith and Dr. Aladjov for their time today. If you have any further questions or if you have any feedback for us, please feel free to email me at ksullivan@ascctalks.org. And everyone have a great day.
Thank you. Bye.
Thank you.